All right. From your unit circle, who wants to tell me what cosine of pi is? -1 is correct. What is tangent 3 pi over 2? Undefined. And what is cosine? Well, cosine of pi was right here, so flip that for secant, and it's still -1. We're dealing with this stuff some more today. Once again, you're going to have to bounce back and forth between degrees and radians probably quite frequently. Did anybody miss a question on the test because you were in the wrong mode?
I had to go back and make sure I had it.
But nobody missed one because they're in the wrong mode. Well, that's good. You're going to bounce back and forth. On these, you should have been in radians. Let's just jump straight into it. All right. Essentially, here's what we're going to do for the first part of today. We're going to give some more trig values. If you were to plot that point, one of these points in the unit circle, if you were to plot this point in the unit circle, -4, 3, it'd be right here. Now, when you are doing a point, when you are drawing a point for trigonometry in the unit circle, does anybody remember what axis you always connect to? Is it the x-axis or the y? Always connect with the x-axis, which would make your angle of interest right here. It's always going to be at the origin, connecting your terminal side of your angle, which is basically nothing more than coming from the origin to your point, and the x-axis. But essentially, here's what you can do all day. Here's the premise for where our triangles are coming from, but here's something you can also do all day. Just every problem, draw yourself an arbitrary triangle and always put theta here. That's essentially what you can do. Because no matter where you draw it, the horizontal part right here is going to come from which of these two numbers? The x. Your horizontal is always going to come from x, even though it may not make sense to put a negative side length. And where's your vertical side going to come from? The y. That's right. So all of these you can do the same way. Put the x here, the y here, do Pythagorean theorem. Your hypotenuse will always be positive, always. And then just find your 6 trig functions. Sine, 3 over 5. Cosine, -4 over 5. Tangent, 3 over -4, etc. Then flip all 3 of them for cosecant, secant, and cotangent. They're all going to work like that. Now you may be saying, what's the difference? Why does it matter? Well, I'll tell you. Because what if you get a point, let me make sure this isn't on the next slide. It's not. What if you get a point like 0, 4? Well, you plot that on the unit circle, and it's here, and you're thinking, how do I make that into a triangle? And it can be a tad confusing. But if you were to draw this out the same way as you always do, and just remember, you always put your x on the horizontal, y on the vertical, Pythagorean, oops, that should be a theta. Pythagorean theorem would get you 4 here as well. If you just get in the habit of doing that, it'll make the trig easier to visualize. What would sine of theta be in this case? Opposite of our hypotenuse, 1. Here's the thing. You wouldn't if you realized, oh, this is just the exact same as pi over 2 in the unit circle. But, you know, because it may be a 4 and not a 1, it might be harder to visualize. So that's why it's just easier if you do this every time. And then cosine, 0 over 4. Tangent, 4 over 0. Undefined. Flip them for your inverses. I want you, real quick, you don't have to write it down, but I want you to find the 6 trig functions, or at least be thinking about, and I'll ask you about them. What are the 6 trig functions for that point? What would the 6 trig functions be for that point? You don't have to write it down. I'm not going to come around and look. But be thinking about it. If you need to draw a triangle and label it and such, then do it. I have a feeling I'm going to need triangles all day today. I'm just going to copy. Oh, crap. Copy. You shouldn't need your calculator for any of these. Well, for this one anyway, to find your hypotenuse. Because when one of your sides is 0, your hypotenuse will always be equal to that side length, to the one that you have. Yeah, but positive. You're right. It doesn't make sense, but it's just going to help you visualize the trig. You're right, because you probably drew it like this, right? And you're thinking, how could that be 0? If you were to graph this on the coordinate plane, it'd be here, and there wouldn't be a triangle. And you might run into questions thinking, well, where do I draw my angle to get my trig? So that's why we just get used to drawing it like this, just to always avoid that. However, sorry, I flashed back with you, brother. On the unit circle, what angle would that be equivalent to? Just looking at this drawing right here. Yeah, exactly. And if you could visualize that, then just use the unit circle. But the triangle is to help so that you can do every question the same way. The x always goes on the horizontal. The y always goes in the vertical. Then you do Pythagorean theorem. That's 9 plus 0 equals c squared. Take the square root. Your hypotenuse will always be positive. So, Sarah Beth, what'd you get for sine? Very good. Opposite of our hypotenuse. Adam, what'd you get for cosine? Got it backwards. Adjacent over hypotenuse, negative 3 over positive 3. Of course, you get the same thing if you reduce it. Cody, what'd you get for tangent? 0 over negative 3, and then just flip them all for secant, cosecant, and cotangent. Questions? All right. Then we're going to go ahead and move on. In exercises 17 through 20, did I skip a slide? Nope, making sure. In exercises 17 through 22, let theta be an angle in standard position. Name the quadrant in which theta lies. If you've got a unit circle, this is all you have to do. On the unit circle, in what quadrant are both sine values and cosine values positive? We'll just look at those coordinates. In which quadrant are both of them positive? 1. That's quadrant 1. That's the answer. In which quadrant are both sine and cosine negative? Quadrant 3. In which quadrant is tangent negative and cosine negative? Now this one might take a little bit more savvy. Well, cosine's negative in 2 and 3, so it has to be in one of those two. That's right. It would have to be 2. Now you can draw what I'm about to do on the board. You probably want to draw this on your unit circle to help you in future cases. On the unit circle, here is your quadrantal breakdown. The first quadrant, cosine is always positive, sine is always positive, tangent is always positive. Yeah, it's going to go. I'm putting it in the same order it should be in your little parentheses. Cosine, sine, and then I'm just sticking tangent on there. Cosine, sine, tangent. In the second quadrant, cosine is negative, sine is positive, and if tangent is sine over cosine, well, positive over negative will be a negative. So that's negative, positive, negative. Just because that's the order it is in the units in the coordinates, isn't it? All your coordinates are cosine then sine, so I just thought I'd do it in the same order. Third quadrant, cosine negative, sine negative, tan positive. And the last one will be positive, negative, negative. So if you have that little chart, that'll tell you the answers right there. Going back to 21, tangent is negative, so it has to be one of these two. Cosine is negative. Has to be, I'm sorry, it's negative, yeah. So it has to be quadrant 2. That's what makes sense. Questions about where we're getting any of the answers from that slide? Let's make up another one. How about you make one up? Take sine, cosine, or tangent, and then tell me positive or negative, and make it up as you go. Make one up at a time. Go. Cosine positive. Okay. Well, these two have a positive cosine. Okay, now pick another one. Sine or tangent, positive or negative. That'll be this one. Cosine is positive, tangent is negative. Your angle would lie in the fourth quadrant. Good. That'll help you because, well, you're about to see why. Yes, it does. Counterclockwise. 1, 2, 3, 4. Good question. Any questions about that slide? Moving along. All right. Find the exact value of the remaining trig functions. So they gave you the bare minimum here. Bare minimum. First of all, number 23, quadrant 3. Now, why are they telling us a quadrant? They're telling us the quadrant so we know what to make positive and what to make negative. Caleb and Chris. Get up. You caught me. There it is. I've been looking for that. Keep it up. All right. Third quadrant. They tell you that you have some phantom angle. It doesn't even really matter what it is. Some phantom angle where cosine is negative 3 over 5. Now, cosine stands for what, Chris? Adjacent over. That's right. Now, the reason the quadrant helps us is because this is negative. Which of these two numbers do I make negative? The 3 or the 5? 3. Because cosine is negative in the third quadrant. And of course, not to mention our hypotenuse is always positive anyway. It really helps you more with tangent than anything. Yep. Then you do Pythagorean theorem.
How did you know that?
Because cosine of theta is adjacent over hypotenuse. Adjacent over hypotenuse. Yep. And the quadrant will let you know which pieces to be negative. So you could go right back to drawing it like this. When you do your Pythagorean theorem, what's your third side? That'd be 25. Well, we're not looking for the hypotenuse. 25 minus 9 is 16. Square root of 16. But because it's in the third quadrant, I know that my y values or my sine values have to be what? Negative. So again, you need to know the quadrant to know which pieces to make negative. In the third quadrant, both my x's and my y's are negative, so that needs to be a negative 4. Once you've got the triangle, everything else is the exact same as what we've been doing. Find the rest of the trig functions. Yes. What are you saying? Well, that was given in the problem. 5. We found this. Yes. And then you know if it's positive or negative by what quadrant it's in. So, from here, sine, negative 4 over 5, tangent, negative 4 over negative 3, and then flip them for the... Yep. This one tells you what quadrant it's in. This one says, you know, it basically tells you it's in the fourth quadrant between 270 and 360. Let's look at 29. 29, let me take this one away. All right. So, if you want to just jump into your triangle, that's fine. Okay. Yes, that is definitely an option. Now, tangent stands for what? Opposite over adjacent. So I know this is 2 and this is 3, and I know one of them is negative. How do I know one of them is negative? Because of the negative, yeah. They couldn't both be, or it was positive. Which one is negative? Is it? Let me ask you this. Sine. Does sine stand for the vertical or the horizontal? Vertical. Is sine positive or negative? It's positive, so the 3 has to be the negative piece. And then Pythagorean theorem, I think is 13, and you can Do it from here.
So, sin sign is the y value.
Always. Yes.
It can't be two because
Say it one
sin
more time.
sign is greater than two.
That's right.
How do you know what your y value is?
Because tangent is opposite over adjacent, opposite over adjacent. It all depends on what the trig function it gives you. You have to use SOHCAHTOA, plug those pieces in. Opposite over adjacent, 2 over negative 2.
No, but I mean, like, the sign is positive. Sign is the y value. How do you know what your y value is?
It told us right here. I'm not quite sure I'm understanding your question.
I think what it's getting at is how you know this one is negative and like sign, you know, it's, you're saying like it's offset over adjacent. So like I can go with sine over cosine.
For tangent.
Yeah.
Right.
So I'm thinking.
Okay, yes. You want to use SOHCAHTOA on these. This whole thing is SOHCAHTOA. Thank you, Hannah. That helps. Any other questions about this one? Yes, sir. It'll always be the y. Well, even on the unit circle, x or y, which coordinate was sine? Sine is always vertical. Cosine is always horizontal. How do we what? You don't, but you don't need to. Well, actually, I guess you could figure it out. Which quadrant has negative cosine, positive sine? Quadrant 2, I think. Did it ask you for that in the question? I don't think it did, but nonetheless, that's how you could, but that's how you could figure it out. Yes. Not yet. One more time. Can? Yeah. Yes. Everybody seems to know what you're asking, so just yes. Let's look at another one of these. Sounds like we're still a tad fuzzy on these, so let's take number 33.
So what exactly are they asking to do?
They're asking you to find the other trig values. All of the other trig, sine, cosine, tangent, all that stuff. And then cosecant, secant, cotangent. Alright. Secant is the flip of what? Cosine. So if secant is negative 3 over 1, what's cosine going to be? Negative 1 over 3. Now we have our random triangle. Always put your theta here. Come on. Alright. Cosine stands for what? Oh, adjacent over hypotenuse. Well, the hypotenuse can't be negative, so which piece has to be negative here? 1. Hypotenuse cannot be negative. Oh, yes. Thank you. Then you can do Pythagorean theorem. I think this is radical 8. And then, you ready for your trig? Sine. Radical 8 over 3. Cosine is given right here. Tangent. Radical 8 over negative 1. And then, it's just SOHCAHTOA from there. Actually, no. It turns out you didn't. The only reason you might need that is if you were curious about which quadrants it was in. Because cosine can be negative in 2 quadrants. Because one of these had to be negative and the hypotenuse can't be. The only time you even have to use some reasoning, because if sine or cosine is negative, it has to be that particular one. The only time you're going to have to use logic is when it's tangent. Yeah, because, yeah. Pythagorean theorem. That's the only way you could have it. You had to use that. Yep. Yep. Sometimes, little curveballs, it might say tangent is positive, and you'll just assume it's a positive number over a positive number. But then it might say something like, oh, cosine is negative. So you have to assume they're both negative if tangent is positive, because negative over negative would give you a positive number. Do they have one like that? Actually, yes. There you go. 31. Classic example. You would just assume it's 4 over 3, but actually, because cosine's negative, that would be negative 4, so it doesn't have to be a negative 4. Yeah. All right. Moving along. Okay, reference angle is the easiest thing you ever do. Reference angle is nothing more than, in fact, we've been doing it already for the last few sections. Reference angle is nothing more than saying, what's the degree between your angle and the x-axis? 160, which quadrant is that in? Quadrant 2. It's about here-ish, right? What is its nearest route to the x-axis? Here or back the way it came? The first one. So what would my reference angle be? 20. Yes, well, I mean, what's the angle of, like, if you were to make a triangle? Now, here's a formula that'll make it even easier if you wish for the formula to find it every time. Technically, there's two formulas, one for radians, one for degrees. They're both pretty self-explanatory. I don't prefer to use the formula. I prefer to just look at it in the unit circle and say, where is it? But here's the formula nonetheless. First of all, in degrees. If you are in the first quadrant, there's one for every quadrant. If you're in the first quadrant, your angle is just the angle it gives you. If it's 40 degrees, well, then your reference angle is 40 degrees. I mean, there's no math to do. What about that one we just did? How did you get 20? We did 180 minus our angle, right? That's the formula. 180 minus our angle. So if it's 110 degrees, your reference angle is 70. 180 minus your angle. If it's in the third quadrant, let's say you're at 210 degrees. 210, 180, what's your little angle here? 30. So you just flip it. Your angle minus 180. You got it. Because that connects it to the y-axis, not the x-axis. That's a good question. The radian one is pretty much the exact same thing. The only difference is instead of angle measurements, you have to use radian measurements. So it'd still just be theta. It would be pi minus theta. Theta minus pi. And 2 pi minus theta. Caleb, Chris, last warning. You wake him up in a way. Oh, good. Last warning. Stay up. All right. So, only thing you might have to do sometimes is find a coterminal, because some of them are obviously not on your original unit circle. So, like, you take 59. Is that too big or too small? Well, it would be too big if it was positive, but it's very good. So we have to add 2 pi, which is what over 6? Well, I wrote it. Never mind. You have to add 2 pi. Still too small. So you add 2 pi again. I'm just going to kind of jump the gun. When you add 2 pi again, still too big. Add 2 pi again. Finally, 11 pi over 6. Which quadrant is that in? Fourth. So you come over here to your equation. 2 pi minus 11 pi over 6. So that's the same as 12 pi over 6 minus 11 pi over 6. And what's your reference angle? Pi over 6. Is that what you said? Good job. Hola. Get out. Thank you, sir. Give me my paper. Thank you. Are there any questions about how we're going to get our reference angle? Does somebody want to see another one of those? Is there another problem on the board somebody would like to see? No. Okay. Which one? Oh, that is an excellent question. That, one second, is an excellent question. 4.7, does that have a degree symbol on it? It is a radian. So, you have to kind of do some thinking. pi is what? 3.14? 3.14, 3 pi over 2, punch in your calculator is like 4.6 or something. So, well, you'd have to use that kind of math, like is it between 3.14 or 4.6, whatever. You have to do that to figure out which quadrant it is in, and then you'll still do one of these. Yeah, or you could just convert it to degrees and do it like that. Times 180 over pi. You don't stick a pi on it. It would just be 4.7 times 180 over pi. Okay. Oh, you mean like 1 point something pi? I don't think it'll stick pi on the top though. Well, sounds like that's in the third quadrant, even if only by that small margin. Yeah, it'd be 89 degrees. All right, good questions. It doesn't say round, so just go to the nearest tenth, I guess. Oh, jeez. Just use the calculator.
Yeah.
Just use the calculator. As long as you know how to find a reference angle, that whole thing is way much longer than it has to be. Again, use the calculator. Yeah, well, you know what? We're bosses of the book. What's it going to do? You can use the calculator on this one too. You can pretty much use the calculator from everywhere else. We're going to stop, however, at 92. They're pretty quick problems. You're welcome. You're lucky I'm immune to sarcasm. This is 4.4. Stone chapter 4. Yeah.